Welcome everyone. Today we've got our fourth lesson and we're going to focus on number patterns today. Number patterns is a fairly large section. It's not huge, but if you understand the basics, then it's fairly easy to score your marks because there are a couple easy questions that you're going to get with your number pattern section. So let's get straight into it. Your notation is important. You need to know what each of these Tn and n and all of that means. So this is an example of a general form for a linear number pattern. Tn is telling us the term value, and it is for the nth term. So in this case, Tn for the nth term is equal to 7n minus 4. N is the position we're in. So I could look at T1, that would be saying what is the first number in the pattern, and all I could do is substitute in a 1, 7 minus 4, and we get that the first term of my pattern is a 3. So if you were to write out a little table of your position and the value, we'd get the first position gives us a 3. We could work out the second position if we wanted to, 7 times 2 minus 4, and we'd get 10, and so on. Let's do the third one as well. The third position would be 7 times 3 minus 4 to get our answer of 17. And we could continue this pattern. So normally all we see is this Tn part. We'd see 3, 10, 17, and then we could be asked a whole bunch of different questions. But it is really important you know the difference between Tn and n. Tn tells you what the actual number is, and n is telling you the position. Is it the first term, the second term, etc. You have linear number patterns and quadratic number patterns in grade 11. Now, for linear number patterns, you need to know that there is a constant first difference. So if I go back to this last example, this was a linear number pattern, and we can see that there is a constant difference between all these terms. From 3 to get to 10, I add 7. And from 10 to get to 17, I add 7. And if I worked out term 4, we would see that I would need to add 7 to get there. So this is called a first difference. It's the difference between my number patterns, the value of my number patterns, and we see that it is constant. So this is my first difference, and for a linear number pattern, we can see that it is constant. So that's the first thing you need to know for a linear number pattern. The other thing you need to know is the formula for how to find the general form, or the nth term, which I've written up here. Tn is a plus n minus 1d. Sometimes in different textbooks it calls it bn plus c. In the end you end up with the same thing. So the method I'm going to show you today might be slightly different to how you've done it in the past, but if you're comfortable with that method you can continue. Otherwise, with this formula, A is always my first term. N, like we just discussed, is the position, and we just keep it general when we're finding the nth position. And D is the first difference. Okay, because it is the constant first difference. It's going to be the same for every single term. So this is the formula that you can use to get the general form, or the nth term for your linear number pattern. And we can ask you a whole bunch of different questions. Write down the next term in the pattern, find the nth term, or find the general term. There are different ways of phrasing this question. Write down find the value of a specific term. So I could say, what is the 20th term in the pattern? Or I could say, which term, which position gives me 560? So finding which term is equal to a specific value. That's pretty much what you need to know. And if you can do all of these 4 steps, then you can apply that to any extra, more challenging questions you might see. Let's go through an example and have a look at those questions. So sometimes your question will tell you if your pattern is linear or quadratic, sometimes it won't. So here they've told us it is a linear pattern, but they actually didn't need to tell us the linear pattern, that it was linear, because what you will always do as your first step is work out a difference table. So from 5 to get to -2, we subtract 7. Now it is important to know whether you're adding or subtracting. So add in that sign. From 2 to get to -9, we subtract 7. And so we can see that this first difference is constant. They did tell us it was linear, but if they didn't, we would have been able to identify that it was linear by our difference table. So first question is write down the constant first difference, and it is -7. Make sure you've got that sign as well. Okay, it's not just 7, it is -7. My number pattern is decreasing by 7 each time. Our second question, write down the value of T4. So we're asked to extend the pattern. We've got 5, -2, this is the first term, the second term, the third term. So they're asking for T4. So I'm going to take my -9 and subtract 7 to get T4, which is -16. So if I were to continue this pattern, I would subtract 7, which would give me the fourth term of the pattern. So -9 minus 7 to get T4. Then it says calculate the number of terms in the pattern. It's a bit of a roundabout way of asking the question. But what we see in this number pattern is that it stops at -289. So they are asking you, we've continued for a while, which position, what is the position number that will give me -289? And in order to do that, we're going to have to find the general term or the nth term or the general formula for this number pattern so that I can create an equation and solve for n that gives me this -289. So from the previous slide, we saw that Tn can be written as A plus n minus 1d, and A is our first term. N minus 1 stays as n minus 1, and my constant difference is -7. Please remember the sign, and also please remember the brackets. If you wrote 5 plus n minus 1 minus 7, we are no longer multiplying these two together. We're subtracting, but we need to be multiplying, which is why your brackets need to come in, and then it becomes multiplication. You can multiply this out. We get 5 minus 7n plus 7, which gives us a general formula of -7n plus 12. So that tells me any term in this pattern can be worked out by using this formula. So if I wanted T1, I could say -7 times 1 plus 12. Which does give me 5. Or I could work out T2 or T3. What I'd suggest you do is test it. So generally don't pick the first number in the pattern, but maybe T3. So let's do a test. I'll do it in a different color. Let's test to see if this works for us. So T3, according to my pattern formula that I've worked out, is -7 times 3 plus 12. And if you work that out, you get -9, which is exactly what we got in our third position. So I've done a check and I can see that this is in fact the correct formula. Now I can go on and solve the question that they're asking. Calculate the number of terms in the pattern. They are asking me which term is equal to -289. They are asking me to calculate n when I know Tn is -289. So Tn is -289. Find or calculate n. That is what this question is asking me. So I'm going to use the formula that I've just worked out, and I'm going to substitute in negative 289 in the place of Tn. It is the value of the number pattern. So I get negative 289 is equal to negative 7n plus 12. And we've got a linear equation that we need to solve. So negative 289 minus 12, we get negative 301. And to get n by itself, we divide that by negative 7 to get 43. So this tells me that there are 43 terms in the pattern. And that is my final answer, 43 terms in this number pattern, since the last term is in the 43rd position and we've stopped there. All right. One thing about n, when you're solving for n is the position of your number, and it will always be a natural number. In other words, a 1, a 2, a 3, a 4, a whole number, but greater than 0. So no decimals, nothing like that. And if you get an n that is a decimal, you know for sure you've gone wrong, and you go back and you see where you've made your mistake. So that is a trick to always remember n is a natural number. Right, let's look at another, or let's go on to quadratic number patterns. So these are your linear number patterns, which you would have done in grade 10. Quadratic number patterns are new in grade 11. Your quadratic number patterns have a constant second difference. So their first difference isn't constant, but if we find the difference between the differences, we find it's constant. And your general form is an squared plus bn plus c, which should look familiar, since that's what we get for quadratic equations. Quadratic formula looks like this, and they're all related. Just going to jump to an example to show you the second difference. So we'll come back and do this question, but here is a quadratic number pattern. So we can see what the second difference is. Our first difference here, from 3 to 5, we add 2. From 5 to 8, we add 3. From 8 to 12, we add 4. So we can see that the first difference is not constant. It keeps changing, 2, 3, 4, etc. But if we work out the second difference, from a positive 2 to a positive 3, we add 1. And from a positive 3 to a positive 4, we add 1. We can see that our second difference is constant. And that is what makes it a quadratic number pattern. Now, going back to what I've written on the screen here, I want to show you where the formula comes from for finding the general form. You probably won't be asked something like this, but I find it's always nice to understand where something comes from, or even to know that there is a real reason for it, and then you can learn it and use it. So what I've done here is I've used this general form, and I have written out my first term, second term, third term, and fourth term. We could obviously go on and write down the fifth and the sixth term, but it's unnecessary for this purpose. So in the first term, my n value is 1. So a plus b plus c, if I substitute in a 1 in the place of this n. If I write down my second term, so substituting in a 2, I'm going to get 4a plus 2b plus c. The third term, if I substitute a 3 in the place of n, I get 9a, 3 squared a, plus 3b plus c, and I've done it for 4 as well. So what we can see is, if I look at my first difference here, from a plus b plus c, to get to a 4a, I had to add 3a. To get from a b to a 2b, I added b, and c to c, there's no difference there. From 2 to 3, from 4a to get to a 9a, I had to add 5a, and from a 2b to a 3b, I add b, and from term 3 to term 4, 9a to 16a, we added 7a. 3b to 4b, we added a b. So we can see that the first differences in the general form are not constant. But if we go and look at the second difference, from 3a plus b to 5a plus b, I added 2a. And we can see it works here as well. 5a plus 2a gives me 7a, and from b to b, we don't add anything. Now, this shows me how I can find my general form or my nth term. The second difference is equal to 2a, and that a we're talking about is the same as this a over here. And then the first term of the first differences is equal to 3a plus b, and that a and b are the same from our original form. And my first term is equal to a plus b plus c, which will then help me work out the value of c. Now, I will show you how we do this in an actual example now, but you need to remember these three formulae if you're going to use this method. This 2a, this 3a plus b, and this a plus b plus c. The rest of it you don't need to memorize, but these three are really important for finding the nth term of our quadratic number pattern. And when we are solving these questions, we always start from the bottom and work our way upwards. So from the second difference to the first difference to the first number in the pattern. Let's go and look at how we would do that for this particular example. The question says determine the value of T26. In order to do that, I need to have a general formula, the nth term for this pattern. So this came from a past paper. It was worth 6 marks. Most of the time they will scaffold it for you. So ask questions like number 1, find the general term, number 2, etc. So we're going to follow all those steps for this question. So I need to figure out what is Tn in the form an squared plus bn plus c. So I always start by drawing a difference table, which I've done over here, and make it part of your working. It is often worth a mark. So don't just do it in your head or as scrap work on your exam paper. Write it into your answer book. So what we saw from the previous page is that this first the second difference that we see is equal to 2a. The first difference is equal to 3a plus b, and the first term is equal to a plus b plus c. Those are the three you need to remember. Okay, this is where they came from. You don't need to remember how we arrived there, but you do need to remember these formulae. So when I'm solving for a, I'm going to say, well, 2a is equal to 1, so a is equal to a half. Then I move on to 3a plus b is equal to 2. I already know a is a half. And so b is 2 minus this 3 times a half, which gives me a half as well for b. And my last one, a plus b plus c gives me 3. I know a is a half, b is a half. So that tells me c is equal to 2. So my general formula for this number pattern is a half n squared, that's my an squared, plus a half n plus 2. And often that's the first question they'll ask you. Write down the nth term or find the general form or general formula for this number pattern. Now I can apply this and answer the question that we're interested in here, which is determine the value of T26. In other words, find the 26th term in the number pattern. So I can write T26 is equal to And now everywhere where there was an n, I'm going to replace it with 26, since I'm trying to find the 26th term in the pattern. And then I'm going to solve it and get my answer. Oh, sorry, I did not mean to do that. There you go, we're back. So I'm going to write my answer here, I don't have space. If you sub this into your calculator, 1/2 times 26 squared plus 1/2 times 26 plus 2, we get our answer of 353. That is the 26th term. It's really important that you know the difference between finding the 26th term, like we did over here, and this previous question here, where we were finding which position gave us negative 289. So here we were given the value of the pattern. So the value of the pattern is our Tn, and it came here in the formula. It came on the left-hand side as the Tn value. And we solved to find n. In this example that we've just done here, we need to know what is the value of the pattern, but I do know that n is 26, so I've subbed in 26 as the value of n, and my answer is the actual number in the pattern. So make sure you read your question carefully and you know exactly what they're asking, which way they are asking it, so that you don't have any issues. If we were to kind of put this in our number pattern that we've got here, we can see if we were to continue this pattern, eventually we would get to a value of 353. It's a number in my pattern, and that's the first number, the second, the third, the fourth. This would be the 26th number, but its value is 353. All right, we're going to just carry on with examples. These all come from past papers, common tests, and even the exemplar papers from 2013. So you can go and have a look at them. They're all available on the Department of Basic Education's website. And they're really nice because we can see how they are asked in an exam situation. So once again, this question has given us, they've told us it's a quadratic number pattern. They didn't have to, and sometimes they don't. And you have to then decide, is it quadratic or linear? In order to do that, you look to see whether it has a constant first difference or a constant second difference. And in our case, quadratic is going to be a constant second difference. Question 1 says, show that the general term of the quadratic number pattern is given by, and they've given you the formula. Show that questions tend to be answered poorly, because people don't understand what it means to show that. Show that, the reason we ask show that questions is just so that you don't take an error from this question and make errors in the following questions. So we're giving you the answer to make sure you don't make mistakes on mistakes, but you should interpret this question as determine the general term, full stop, from scratch. Do not use that, the answer, to prove or to show. You are going to determine this by yourself from scratch. So ignore it, forget about it, just use it to check your answer at the end. So our first step is to figure out our table of differences, our difference table. So I'm going to write out our pattern again, -7, 0, 9, 20, and it continues. My first difference here, from -7 to 0, we add 7. From 0 to 9, we add 9. And from 9 to 20, we add 11. So we can see that our second difference is constant, and it is a +2. We add 2 each time. So yes, it is quadratic. Remembering our little formulae, 2a is equal to the second difference. 3a plus b is the first difference, and a plus b plus c is our first term. You can pause the video if you're watching the recording and try it yourself, but let's go through it. 2a is equal to 2, so a is equal to 1. 3a plus b is equal to 7. We know a is a 1, and so we can work out b to be 4. And a plus b plus c is equal to -7. So 1 plus 4 plus c is equal to -7, which means c is equal to -12. Therefore, Tn would be n squared plus 4n minus 12. And then I check and I see it is the same as the question. And so I know my answer is correct. But nowhere did I start with this and show that the numbers worked. That's not what they're asking you to do. You may not use the answer to prove that it works. You have to start from scratch. And that holds for any show that or prove that questions. You ignore the answer that they give you in the question and you start from scratch. You just use it to check your work. If you don't get what they've given you, you can try and fix it, find where your error is, or when you move on to the next question, you use the answer that they gave. You don't use your incorrect answer. Right, our second question, which term of the quadratic pattern is equal to 128? Which term? That is saying find n. What is n when the number pattern is equal to, so this is a Tn value. So my number pattern is equal to 128. So I'm going to substitute Tn as 128. So I'm going to do it on the side here so you can still see, my board. Let's just take up some space here. So this is for our second question. Tn is 128. So 128 is equal to n squared plus 4n minus 12. So we are now solving for n. It will work out to be a quadratic number pattern, a quadratic equation rather, and that comes up all the time with grade 11 and grade 12 work. So if I move that 128 over, I get negative 140. And now I need to solve this equation. So it is a quadratic number pattern. I need to factorize or use my quadratic formula and solve. Now, you're going to get nice whole numbers when you're dealing with number patterns. So don't be scared to factorize. But if you can't find the factors, you can use your quadratic formula as long as you show the substitution. Now, the numbers that work in this case are -10 and 14. Since -10 times 14 is -140 and -10 plus 14 is 4. So solving this, I see n is either 10 or n is -14. Remember what I said at the beginning, n is always a natural number, which means this solution is not applicable for the context we're in. We're dealing with number patterns. N is a position. So it cannot be -14. Then I conclude n must have been 10 because I can't have the -14th number in the pattern. That makes no sense. All right. We've kind of covered all the general basic type of questions they could ask you. And if you understand these, then you can apply it to the more complex questions, which we will see now. They're just slightly different. Here we have the same quadratic number pattern. So it's the same example continued. It asks for the general term of the first differences. So it is asking us not for the general form or the general term for the quadratic pattern. It is asking us about this process or this sequence of first terms. So it is saying, consider a new number pattern, 7, 9, 11, and so on. What is the general form for this pattern? And now what you should notice, and what is true all the time for quadratic number patterns, is that its first difference pattern, this 7, 9, 11, etc., is a linear pattern. It will always be that case. If you have a quadratic pattern to start with, then its first differences will be linear. So we still need a difference table. We know this already, but now we are going to use the formula Tn is A plus N minus 1D. Since this pattern is linear, and I can see that since it has a constant difference. So the general term of the first differences, I've taken my first differences and looked at this as a new pattern, and I see that it is linear, and I can write down my general form. A, my first term is 7, D is 2, so I get 7 plus 2n minus 2, so Tn is 2n plus 5. That is the general formula. We can do a check once again, so I can do it on the side here. Let's check T3. According to my number pattern, it should be 2 times 3 plus 5, which is 6 plus 5, which is 11, which is what I'm expecting. So I know that my formula is correct. So we're still on the more application questions, still the same example. Determine between which two terms of the quadratic pattern the first difference is 599. Now, there are two ways to do this question. I'm just going to show you the simple way. We've just calculated the general formula for the first differences, and it follows 2n plus 5. So when they're asking me when is the first difference 599, they are asking me in this linear pattern that I've just worked out, my Tn value is 599, figure out the position. So I'm going to substitute 599 into this formula. And solve for n. It's a linear number pattern, so I can subtract the 599 minus 5 to give me 594 is equal to 2n. Solve for n by dividing by 2, and I get 297. But now, if we read the question again, which is always a good thing to do, make sure you've answered the question and you haven't just stopped halfway. It says between which two terms of the quadratic pattern will the first difference be 599? We've solved for n. We've just got one value. We need to figure out in our quadratic pattern between which two terms do we have. So what I like to do is write out my quadratic pattern again. -7, 0, 9, 20, etc. This is my first term, my second term, my third term, and my fourth term, and I need to figure out one of these terms. Okay, I know that my first difference here was +7, and that was the first term of my first differences. Then 9 was the second term of my first differences, and 11 is the third term of my first differences. I've worked out that 599 is the 297th term of the first differences. Okay, that's what this has told me. In this linear number pattern here, the n value is 297. The question is saying between which two terms of the quadratic number pattern. So it's asking me for these values. So if we look at what we've just done here, this number 1 is between 1 and 2. Number 3 is between 3 and 4. So number 297 must have been between terms 297 and 298. So just following the pattern that we see. So my answer is between term 297 and 298. Or you could have written it as T297 and T298, between these two terms. So that's just an extra application, and I wouldn't learn it as a rule. I would just work it out each time by drawing up a difference table like this and seeing what makes sense. Another application question, which is more of the complex or side of things, but we're going to go through it. Determine the largest value of n for which the pattern value is less than 468. So we've worked out how to calculate the n value of a pattern, which is what we did here, which term is equal to 128. But now we're asking, determine the largest value of n for which the pattern value is less than. So we're no longer dealing with an equation, but rather we are dealing with an inequality. Okay, so let's use our general formula, which we had over here, which was n squared plus 4n minus 12. We worked that out previously. We're still dealing with the same pattern. N squared plus 4n minus 12. Just check that's correct. Yep. They are saying we're solving for n. So n is going to stay as our unknown. But the pattern value must be less than 468. In other words, Tn, this thing, is less than 468. And they want your marks. Solve this. Let's go on and solve this. We can rearrange so that everything is on one side. So if we take our negative 12 and subtract 468, we get negative 480, less than 0. So if you remember our previous lesson on quadratic inequalities, this should be fine. We have our everything on the left less than 0. We need to factorize so that we can solve our critical values. So you can factorize this, or you can use your quadratic formula, whichever one you are more comfortable with, but I suggest factorizing. It just makes it easier and your setup is better. But we end up with these two as our factors. Negative 20 times 24 gives me negative 480 if we multiply, and gives me positive 4 if we add. So my critical values are 20 and negative 24. I could put that on a number line. I could substitute in values to see whether it's positive or negative. And what we see, if I substitute in a number, say less than 124, I get a positive value, a negative value, and a positive value, or however you want to solve inequalities. So normally, if this were just an algebra question, I would say between negative 24 and 20. But now they are asking me the largest value of n. So I still want this thing to be negative, less than 0, negative here. But I want the largest value that is in this negative section. Now I can't say 20, because at 20, it will be equal. So I need the number, the n value just below. So n will be 19. It's the number just below here. And you can always check it. So I'm going to do my check here in a different color. T19, if I substitute 19 squared plus 4 times 19 minus 12, we can get our answer. which is 425. And if I work out what T20 would be, we would see that it is slightly bigger. So let's work out T20. Which gives me 468, exactly. So the n value that is less than 468, not 480, 468 is what we get, is definitely 19. All right, our time is running a little bit short, so I might do one more example. We can look through this one here. Given the linear number pattern, write down the fifth term in the number pattern. So we would write out our difference table and then just follow on, give the next term in the pattern, and we could determine a general formula, which we have done previously. Okay, so this is just another example of how we could ask a linear number pattern question. Which term of this linear number pattern is the first term to be negative? That's very similar to the previous one I've just done. And here they're talking about the sequence of first differences of a quadratic pattern. So they are saying this linear number pattern is the first difference for a quadratic number pattern. And in our last couple minutes, I think I'm going to do this question. So we've got 156, 148, 140, 132, and they are saying it is the first difference of a quadratic number pattern. So there's going to be a number and its difference will give me 156. The difference between these two numbers will be 148, 140, and 132. So this is the first term of my quadratic pattern, the second term, the third term, the fourth term, and I can add in the fifth term as well. So it's a quadratic number pattern. I'm looking for the general formula. And in order to do that, I need the second differences. So 148 minus 156, we see that we subtract 8 each time here. So from this, I can see that 2a is negative 8. I can see that 3a plus b is 156. So if we solve for 156, we get 168 for the b value. And then the only issue is, what is our c value? And they've told me that T5 is negative 24. So what I can do is I can substitute in here a negative 24 and work my way backwards. So if T5 is negative 24, then T4, if I subtract 132, is going to be negative 156. Subtract 140 because we're moving backward. This term is negative 296. Subtract 148 to get negative 444, and subtract 156 to get negative 600. So that tells me A plus B plus C is negative 600, my first term. And I can solve for the value of C. So negative 600 plus 4 minus 168 gives me my C value, which is negative 764, and Tn is negative 4n squared plus 168n minus 764. That is where I'm going to stop today because we have run out of time. If there are any questions, you can ask in the chat. Otherwise, that is the end. As long as you remember linear number patterns have a constant first difference and quadratic patterns have a constant second difference, the most important thing you can remember is this 2a, 3a plus b, and a plus b plus c. Then you'll be fine.